Dear students, welcome to CR's digital classes. Today's concept is F-test. So F-test for testing equality of two population variances also we'll call, because we'll compare variances here. So in F-test we'll check it out the population variances. So we can also call F-test as testing equality of two population variances. So let us check it out how the procedure will go on and what are the formula to obtain our F-test. So F-test for testing equality of two population variances is your heading. Simply F-test also we can call. So let us check it out how the formulas goes on. The objective of F-test is to determine whether two independent estimates of the population variance differ significantly or whether the two samples may be regarded as drawn from the normal populations having the variances. So just now in the introduction I have said we'll check it out the variances here. So from where the variances we are getting that in the introduction we are discussing here. So independent estimates will consider that is population variances which is significantly differ from one another. So the formula goes like this, from normal populations we consider, so obviously variances will be sigma square, because two variances we are considering, one becomes a sigma a square and other becomes a sigma b square, and they are significantly differ we are considering, means they are equal we are considering here. So sigma a square is equal to sigma b square I am considering. Altogether I am considering it as sigma here. So let us check it out how the formula goes on or how the ratio goes on for this. So this test is carried out by following the ratio, that is F is equal to SA square by SB square becomes a formula. Now again, what is SA square, SB square? Let us check it out. SA square is nothing but our population variance formula itself, variance formula itself. So the same formula according to the F test we are just making the little changes, because two variances we are considering, one is with A set, one is with B set. So according to that, let us give the notations for the same variance formula here. So how the formula goes on, let us check it out. SA square is equal to summation A is equal to 1 to N1, because sample size we are considering up to N1. So summation A is equal to 1 to N1 XA minus X bar whole square. So that is a regular our variance formula divided by N1 minus 1. So this becomes your population variance formula for A set. So A notation we are considering over there. Similarly for B set also we have to consider. So here population variance for B set is the same formula with the B values we need to consider, that is summation B is equal to 1 to N2 YB minus Y bar whole square by N2 minus 1. Here samples we are considering y1 to yn like that. So y1 to yn2, because n1 we are giving for set A. So here y1 to yn2, if sample size we have, this becomes your population variance formula. So the usual formula what we have learned earlier, the same thing. Now in F test how it goes on in ratios, let us check it out. So this becomes a ratios formula, just now we discussed it, the same. So we'll take the values and we'll substitute in the variances and we'll get the ratios. Now again for ratios we have condition. How to obtain that ratio we have condition. Let us check it out that also. Here N1, N2 also they have mentioned here, where N1 is equal to first sample size, N2 is equal to second sample size. Yes, it's understood. Sample size is always N. Two samples we have, so N1 and N2 becomes our sample sizes. Now let us check it out the conditions for ratios, how to consider them. So the degrees of freedom are V1 is equal to N1 minus 1 we have, V2 is equal to N2 minus 1 we have. So small samples whenever you are considering will have degrees of freedoms also. So degrees of freedom here we have V1 is equal to N1 minus 1 and V2 is equal to N2 minus 1. So that also we need to consider whenever small samples we are considering. So that is your degrees of freedom here. Next second point, the numerator variance must be always greater than the denominator variance. So this is a condition we have to check it out always whenever you have done population variances using the formula. After getting both the variances, we need to compare the things, whichever is the highest value, that should be the numerator always. So that is a condition for F test. So definitely you have to check it out, the both the variances, whichever is the highest value, bigger value, that should be on the numerator, and the denominator must be the smaller one. Suppose I have a A square, sample A, we got the bigger value, so that should greater than SB square if I have, so I can write the formula for F as F is equal to SA square by SB square. So like that. So ratio, you have to consider the bigger value should be the upside one, that is the numerator one. So now let us check it out one more point. The third point, if sample variance S square is given, we can obtain population variance small s square, capital S square, these are. So sample variance small s square is given, so we can obtain population variances capital S square by using the formula. So sometimes what happens in the data, they will give sample variances, or sometimes they'll give population variances. If it is population variance, usually we can go on. So sample variances are given, so we can convert the data. We know that already. So like whenever we have sample variances and we want to for population variances, we can utilize this formula. So how to convert that one is, whenever we have a sample variances with us, so n s square we can consider as n minus 1 capital S square. So in this way we can convert the data whenever population variances we require using the sample variances. So this is one more point for obtaining our F ratios. So this is your F test, and all the conditions, all the points whatever we require to obtain our F test. So this is a concept of F test for obtaining the population variances. So hope you have understood this concept of F test. See you all in the next session. Thank you.